Hello everyone. In this video, I am going to discuss about the nucleophilic substitution reaction. First of all, what is meant by the substitution? During the chemical reaction, any group of atom or atom can be replaced by some other group of atom is called upon substitution reaction. Now, here I am showing the nucleophilic substitution reaction. So, what is the meaning that the substitution atom or group it must be the nucleophile. So, you know very well in every haloalkane we know that it's a CX bond. So what is a CX bond? The nature of the CX bond, the carbon consists of the less electronegativity, and what about the halogen? It is a more electronegativity. So what will be the negative charge will be formed? So here the it's a partial negative charge is going to be formed, and here the partial positive charge is going to be formed. So when you treat it with it's an aqueous medium, now what will happen? So due to the solvolysis effect, this particular nature of the CX bond, the complete electron transfer is take over. So as a result, what will happen? Here it will form the carbocation and X minus. So what is that halide? Halide, it acts as it's a leaving group. It's a leaving group. So now it's a nucleophile. It reacts with the haloalkane having the partial positive charges on the carbon atom and bonded to the halogen. So now you treat it with the aqueous medium. Now what will happen? The complete electron transfer, it's moving towards the more electronegativity of the halide. So as a result, the carbocation will be formed. So this particular carbocation is going to be attacked by the nucleophile. So now what will happen? I got the substitution, nucleophilic substitution reaction. Okay, this particular carbocation is going to be attacked by the nucleophile. So as a result, what will happen? I got the nucleophile substitution reactions. Okay, so first of all, in the nucleophilic substitution reaction, the nucleophilic substitution reaction can be mainly classified into the SN1 and SN2 and SNI. Okay, SNI. So now in this video I am going to discuss about the SN1 reactions. So what is a SN1 reaction? Point number one, it generally carry out the polar protic solvent. So what is a polar protic solvent? The polar protic solvent usually which is the solvent can make the hydrogen bond towards the substrate. It's a call upon polar protic solvent. For example, aqueous or ethanol or ammonia. So these are all the example of what? Polar protic solvent. Polar protic solvent is different. Polar aprotic solvent is different. And it's a follow the first order kinetics. So the rate of the reaction for the SN1, it's only dependent upon the concentration of the alkyl halide, not with the aqueous base or alcoholic base. Okay, and now this fourth point is very important. Allylic or benzylic halide show the high reactivity towards the SN1 reaction. So why? In that allylic position, I have the carbon-carbon double bond, the second position of the halide. So when you treat it with the aqueous medium, now what will happen? Here the partially positive charge and partially negative charge would be formed. So once you treat it with the aqueous medium, the complete electron transfer is take over. So as a result, what will happen? So in this particular position, it will form the carbocation. So in the carbocation, the single bond with the double bond. Now what will happen? So a resonance effect. So as a result, I got the another resonance structure like this. So same thing happen in the benzylic halide also. So due to the resonance, it will form the stabilizing carbocation. That's why a comparison of the tertiary carbocation, allylic and benzylic carbocations are more stable. And in this reaction, the step number one, it's a formation of what? Carbocation. It's a formation of carbocation. How it is occurred? By the slow reaction and reversible reactions. And what is the step number two? In the mechanism of the step number two, it's a carbocation attacked by the nucleophile. So now the breaking of the CX bond, which energy obtained proton from the protic solvent to produce the carbocation. So let me discuss with the mechanisms. So here I have the compound. What is the compound name? So here the longest chain will be a 3 number of carbon. In the second group, okay, in that 1, 2, 3, in the second position, I have the substitution of methyl and bromine. So what is the compound name? It is a 2-bromo 2-methyl propane. So which will be I treated with the aqueous KOH or either be the aqueous NaOH. So now what will happen? From the alkali base, I can expect that OH hydroxyl group, it is a nucleophile. So this particular nucleophile is going to be attacked with the carbocation. So now what will happen? I got the product of the uh, alcohol functional group. Okay, so this is our product, okay, which will be getting from the SN1 reaction. So what is the name of the reaction? So here I have the longest chain. Give the number 1 2 3. So it is a 2-methyl propane 2 all. I am going to be get that. So in every nature of the CX bond, so in the beginning of the time I explained that. So this is our nature of the CX bond. So this is our nature of the CX bond. So definitely here it's a partially positive charge and partially negative charge will be formed. So when you treat it with the aqueous medium, what will happen? The complete electron transfer is take over. So as the following the mechanism of the step number 1, it's a formation of what? Carbocation. So once the complete electron transfer towards the bromine, okay, it's a bromine, it's a leaving group. Bromine, it's a leaving group. It's a leaving group. So now what will happen? The carbocation will be formed. So here in the substrate of the CX bond, it's a tetrahedral. So once you bond broken towards the bromide anion, now what will happen? I got the change in the hybridization of sp2. I got the intermediate of what? Trigonal coplanar carbocation structure. So what is the step number 2? The step number 2, carbocation attacked by the nucleophile. So nucleophile of the hydroxyl group is going to be attacked towards the center of this carbocation. Now what will happen? OH will be formed. So now in this reaction, instead of that, so here I have the bromine. So here I have the bromine. Instead of this bromine, I got the OH. This is known as the nucleophilic substitution reaction through the SN1 mechanism. So let me work out the some basic examples. So here I have the ethyl chloride. This ethyl chloride I treated with the aqueous KOH, aqueous potassium hydroxide. Now what will happen? I am going to get ethanol. So ethyl chloride, it's converted into ethanol, and byproduct will be it's a KCl. Okay, now I'm explaining with the mechanism point of view. So what is the step number 1? Step number 1, it is a formation of what? It's a formation of carbocation. Okay, how it is formed? First we need to identify what is the nature of the CX bond. So here I have the nature of the CX bond. So in that CCl, hydrogen and CH3. So this is the nature of the CX bond. Here I have the partially positive charge and partially negative charge. So once you treat it with the aqueous medium, it's completely electron transfer will be take over. So as a result, what will happen? It's a CH3, C plus hydrogen and hydrogen. This is a what type of carbocation? It's a primary carbocation I am going to be formed. So what is the step number 2? Step number 2, carbocation, it's attacked by the nucleophile. It's step number 2, carbocation attacked by nucleophile. So here I got the what type of carbocation it's formed. It's a primary carbocation is formed. So in this particular reagent, it's a aqueous potassium hydroxide I am going to be add. So from the aqueous KOH, what type of nucleophile I can expect? A formation of hydroxyl nucleophile. So this hydroxyl nucleophile is going to be attack of the center of the carbocation. So as a result, what will happen? Formation of ethanol. So through the carbon and oxygen, a new chemical bond will be formed and alcohol will be formed. Okay, the leaving group of the KCl can bind with the potassium, and byproducts of the KCl would be formed. Okay, so this is our reactions. So whatever may be in every alkyl halide, if it is in the reagent, from the reagent you need to identify what type of nucleophile it will be formed. Okay, instead of this halide, you can replace with the nucleophile. You got the product of the reactions. Okay.